तो हेलो वेलकम। आज हम देखेंगे कि कंप्यूटर नेटवर्क्स एंड इंटरनेट प्रोटोकॉल का वीक 3 असाइनमेंट नंबर 3। ओके, क्वेश्चन नंबर 1, व्हाट काइंड ऑफ सीक्वेंस नंबर डॉट टीसीपी यूज। ओके, तो कौन सा सीक्वेंस नंबर ट्रांसमिशन कंट्रोल प्रोटोकॉल यूज करता है। ओके, सो इसका आंसर हो जाएगा बाइट ओरिएंटेड सीक्वेंस नंबर, ऑप्शन नंबर ए। बाइट ओरिएंटेड सीक्वेंस नंबर। So byte oriented sequence number क्यों है कि this is the correct answer because TCP assigns sequence numbers to each byte of data that is sent. This allows the receiver to reorder the data correctly even if packets arrive out by order. By numbering each byte, TCP ensures that the complete stream of data that can be reconstructed, regardless of the order in which packets are received. So the sequence number in TCP identifies the position of the first byte in the data segment. Okay? So this is the point. Okay. ऑप्शन नंबर बी क्या था, पैकेट ओरिएंटेड सीक्वेंस नंबर। ये इनकरेक्ट क्यों है, क्योंकि टीसीपी डज नॉट यूज ए पैकेट बेस्ड सीक्वेंस नंबर। ओके, एंड ऑप्शन सी था, यहाँ यहाँ पे और भी चीज गो थ्रू कर सकते हो। ओके, रैंडमली जनरेटेड फिक्स्ड सीक्वेंस नंबर। So this is also incorrect because sequence number in TCP are not randomly generated. They are sequentially assigned. Okay, starting from an initial value during the connection setup, that is the three-way handshaking. Okay, and increment as each byte of the data is sent. So the sequence number is not random or fixed but is incremented with each byte. तो इसका ऑप्शन नंबर ए इज द आंसर। क्वेश्चन नंबर 2, आइडेंटिफाई द फॉल्स स्टेटमेंट्स इन द फॉलोइंग। सो फॉल्स स्टेटमेंट क्या है, इन दोनों में से पूछ रहा है। तो फर्स्ट था कि द ट्रांसपोर्ट लेयर फंक्शनैलिटीज, दैट इज कनेक्शन एस्टेब्लिशमेंट फ्लो कंट्रोल एरर डिटेक्शन, operate at an abstract level using data structures, algorithm and system calls implemented in the OSI kernel। ये ट्रू है क्योंकि the transport layer, that is transmission control protocol, relies on the OS kernel to handle tasks like connection establishment, flow control, error detection. So the kernel implements these functionalities using data structure, algorithm and system calls that interact with network hardware and manage the data flow। Okay? स्टेटमेंट टू क्या था, स्टेटमेंट वन ट्रू है। तो स्टेटमेंट टू क्या था, वन ट्रू हो गया। अच्छा, स्टेटमेंट टू ये था, द ऑपरेटिंग सिस्टम, दैट इज द ओएस कर्नल डज नॉट प्ले एनी रोल इन सपोर्टिंग द ट्रांसपोर्ट लेयर फंक्शनैलिटी ऑफ द टीसीपी प्रोटोकॉल स्टैक। एक्चुअली द ऑपरेटिंग सिस्टम कर्नल प्लेस द वाइटल रोल, यहाँ पे डज नॉट है, सो ये फॉल्स हो गया। ओके, तो यहाँ पे देखो, कर्नेल यहाँ पे दिया है कि कर्नेल डज नॉट प्ले एनी रोल। सो ये फॉल्स हो गया, इसीलिए पहले से बोल चुका हूँ ये, क्योंकि ओएस कर्नेल प्लेज एन एसेंशियल रोल। ओएस कर्नेल प्लेज एन एसेंशियल रोल, यहाँ पे दिया है कि डज नॉट, तो यहाँ पे एसेंशियल सो फॉल्स हो गया। ओके, तो यहाँ पे फॉल्स हो गया, इसलिए यहाँ पे डज नॉट लिखा है स्टेटमेंट में, तो ये OS kernel plays an essential role। एक्चुअली यहाँ पे does not play an any role लिखा है, so false हो गया। In supporting transport layer functionalities, it manages the lower level abstract of the network communication, including packet routing, memory buffers, error handling, okay, and any management of the socket interfaces used by higher layers such as transport layer, that is transmission control protocol or else user datagram protocol, TCP or UDP। So false। So यहाँ पे only two option false है, B, D option, only two option false। Question number 3, which of the following services is not supported by transport layer। So transport layer में कौन सा सपोर्ट नहीं करता है सर्विसेज। सो एंड टू एंड पैकेट डिलीवरी सपोर्ट करता है, ऑर्डर पैकेट डिलीवरी सपोर्ट करता है, रिलायबल डाटा डिलीवरी ये भी सपोर्ट करता है, बट फॉरवर्डिंग द डाटाग्राम फ्रॉम वन हॉप टू अनदर हॉप इन द नेटवर्क, ये नेटवर्क लेयर का काम है, ट्रांसपोर्ट लेयर का नहीं है। सो दिस डी ऑप्शन, ओके, नॉट सपोर्टेड बाय द ट्रांसपोर्ट लेयर। सो यहाँ पे हम देख लेते हैं इसका एक्सप्लेनेशन। Let's analyze the option carefully to determine which services is not supported by the transport layer. पहले से बोल चुका हूँ, ऑप्शन है एंड टू एंड पैकेट डिलीवरी, ये सपोर्ट करता है, सपोर्टेड. So the supported layer ensures end-to-end communication between source and destination process using protocols like TCP and UDP. Then option B, order packet delivery, ये भी supported. TCP ensures that packets are delivered in order using sequence numbers and retransmission mechanism. Then option C, reliable data delivery, it also supported. TCP provides reliable data delivery using acknowledgement, that is SCK, error transmission and error checking. Okay. UDP on other hand is unreliable. Okay. TCP reliable, UDP is unreliable. And here option D is the false statement. Okay. False means not supported. Forwarding the datagram from one hoop to another hoop in the network. So Q not supported here, Q is a network layer. That is layer number 3. This is not the transport layer. Okay. So the network layer, that is internet protocol, that is IP, is responsible for routing and forwarding the data packets from one hoop. Hoop means router to hoop क्या है router to another until they reach the destination, means hoop to hoop delivery. Okay. So ये option D हो गया. Yes. Question number 4. What can be a primary mechanism used to ensure the reliable data transfer in a stop and wait algorithm? That is noisy channel. Okay. So रिलायबल डाटा जो स्टॉप एंड वेट प्रोटोकॉल है, तो उसका प्राइमरी मैकेनिज्म क्या है? ओके, टू एंश्योर द रिलायबल डाटा ट्रांसफर इन द नॉइजी चैनल. ओके, सो इसको देख लेते हैं. लेट्स एनालाइज each and every option to determine the primary mechanism used to ensure reliable data transfer in a stop and wait algorithm over a noisy channel. तो ऑप्शन ये था employing only error detection and correction codes without requiring acknowledgement. So ये correct. Q incorrect है. While error detection, that is checksum or CRC, means cyclic redundancy codes, and error correction, that is the Hamming codes, okay, helps to identify and fix errors. They do not handle lost or dropped packets without acknowledgement, that is SCK. There is no way to confirm successful delivery. Okay, so ये incorrect हो गया. Option B, that is to, increasing the time out interval. Okay, increasing the timeout interval. So ये incorrect क्यों है? A timeout mechanism helps to detect lost packets, but simply increasing the timeout does not guarantee the reliability. So if the timeout is too long, so retransmissions become slow, reducing the efficiency. Okay? So ये false हो गया, incorrect. Option C, using a sequence number to identify each packet uniquely and waiting for an acknowledgement for each packet before sending the next packet. So ये correct है क्योंकि this is the core mechanism of stop and wait ARQ. Okay, stop and wait ARQ means automatic repeat requests. So Q है ये correct, ये Q core mechanism है क्योंकि number one sequence number to help distinguish to the new transmissions from retransmissions. Okay. So second one, the sender waits for an acknowledgement before sending the next packet. Third one, if an acknowledgement is lost or a packet is corrupted, so the sender retransmits after a timeout. This ensures reliable delivery over a noise channel. Okay. So option D है कि using a sliding window. तो ऑप्शन सी करेक्ट हो गया. डी ऑप्शन को देख लेते हैं. डी ऑप्शन क्या है? यूजिंग a sliding window to send multiple packets without waiting for their acknowledgement. So ये incorrect है. Q incorrect. The sliding window protocol usually go back in ARQ and selective repeat ARQ, not in stop and wait protocol. Okay. So stop and wait only allows one packet to be in transmit at a time. Okay. So option C is the correct answer. Using a sequence number to identify each packet uniquely and waiting for an acknowledgement for each packet before sending the next packet. Question number 5. ये न्यूमेरिकल है. A data of 40 bytes need to be delivered using TCP protocol, but the sender can send a segment of maximum size of 12 bytes only. Identify the sequence number of the last segment formed if the sequence number field uses 5 bits only. So assume sequence number starts from 0. Okay. So step by step solution here, we need to determine the sequence number of the last segment formed in a TCP transmission under the given constraints. So ये information given है कि total data size 40 bytes, maximum segment size that is MSS that is 12 bytes, sequence number of field size that is 5 bits. Okay, so number of ranges that is 0 to 31 means 2 to the power 5 is equal to 32. So range कितना होगा 32 0 to 31 and wrap around after 31. Okay, initial sequence number that is ISN equal to 0. So step 1, determine the number of segments. Since each segment can carry a maximum number of 12 bytes, we divide the total data. तो total segment कैसे होगा? Total segment find out करने के लिए total data divided by segment size. So 40 by 12 that is 4 rounding up. So second step, calculate the sequence numbers. So since TCP uses byte-oriented sequence numbers, each segment sequence number represents the first byte number of that segment. So यहाँ पे 4 segment है, तो start से sequence number 0, first का 0, second का 12, third का 24, fourth का 36. यहाँ पे bytes transfer है, bytes transmitted क्या है 12 that is 0 to 11, 12 that is 12 to 23, and that is 12, 24 to 35, then 4, 36 to 39. So next sequence number that is 12, 24, 36 and 40. So step 3 में applying 5 bits wrapping, since the sequence number field is 5 bits, so अपने बोला था कि 32 ranges from 0 1 to 31. Okay, so 32 it ranges from 0 and 31. So when the sequence number is exceeded 31, so it wraps around. So 32 is range from the value 0 to 31. So as 31 exceeded, it wraps around. So first segment starts at 0, second 12, third 24, fourth 36. But since 36 more 32 equal to 4, the last segment actually starts at sequence number 4. So final answer 4. Option number B. Question 6. A sender uses a sliding window protocol with a window size 5. The range of sequence numbers allows module 8. The sequence number starts from 0 to 7. If the receiver acknowledgement packet 1, so what will the sender's new window size range? Okay. So understanding the sliding window protocol first. Window size क्या दिया है 5, sequence number range 0 to 7, module 8. The window will shift forward when the sender receives an acknowledgement for a packet. So actually what happened when packet 1 is acknowledgement actually. So when the receiver acknowledgements packet 1, so it means that the sender can slide the window forward by 1 position. So this follows the sender to send the next packet in the sequence. So step by step explanation नहीं होगा कि initial sender's window, that is the window size is 5, so sender can transmit packets that is 0 to 4, 0, 1 to 3 and 4 initially. So the window range before acknowledgement that is 0, 1 2 3 4. So after acknowledging packet 1, so the acknowledgement of packet 1 that indicates that the sender can remove the window forwarded by 1 position. So it can, so packet 1, so यहाँ पे देखो the acknowledgement of packet 1 indicates that the sender can move the window forwarded by the 1 position. So after moving forward, the sender can send packets, that is क्या send करेगा packets that is 2 3 4 5 6. Okay. So as the sender can send the packets that is 2 3 4 5 6, so the new window range क्या हो जाएगा, the new window range हो जाएगा 2 3 4 5 6, that is 2 to 6. 2 to 6 कौन सा ऑप्शन है? ऑप्शन नंबर बी. ओके, 2 to 6 ऑप्शन नंबर बी में है. क्वेश्चन नंबर 7, डिटरमाइन वेदर द फॉलोइंग इंफॉर्मेशन इज ट्रू और फॉल्स. सो स्टेटमेंट ये है कि ड्यूरिंग द थ्री वे हैंडशेकिंग ऑफ कंप्लीशन एस्टेब्लिशमेंट प्रोसीजर फ्रॉम होस्ट 1 to host 2, delayed duplicate synchronization can be handled by TCP and host 2 simply by ignoring it. Simply by ignoring it. So as the sequence number is invalid. So यहाँ पे स्टेटमेंट ट्रू होगा क्यों? क्योंकि ड्यूरिंग द थ्री वे handshake, the TCP connection establishment host 1 sends a SYN packet to initialize, means to initiate the connection, and host to respond with the synchronization followed by acknowledgement, the synchronization. Okay, host 1 then sends an SCK to finalize the handshake. So if delayed duplicate SYN received by host 2, so it will ignore the duplicate because number one, TCP uses sequence numbers. So each SYN packet has a unique sequence number. If a duplicate SYN is delayed and arrives after the initial SYN SCK response, so it will have an invalid sequence number. So invalid sequence number, the host 2 has already processed the first SON and sent the SON SCK. Okay, the delayed duplicate SON will not match the expected sequence number. Yes, match नहीं करेगा. As the result, host 2 will ignore by default. So यहाँ पे match नहीं करेगा SON. So host 2 ignore हो जाएगा. So therefore TCP and host 2 can handle delayed duplicate SON packets by simply ignoring them because the sequence number will be valid. So यहाँ पे हो जाएगा that is true. Question number 8. TCP instances use a sliding window protocol in a noisy channel. A timeout occurs due to the loss of segment or the acknowledgement. Mark the right segment among the following. So sliding window protocol. Okay, TCP instance uses sliding window protocol in a noisy channel. Okay, yes, a timeout occurs due to the loss of a segment or the acknowledgement. Map the right segment. Okay, so यहाँ इसका explanation ये होगा कि देखो go back in ARQ में in go back in ARQ में okay in go back in ARQ में if any segment in the sliding window is lost, so all subsequent packets in the window are retransmitted regardless of whether they were received correctly or not. So the receiver expects packets in order or any lost packet causes the sender to resend all the packets after the lost one. तो सिलेक्टिव रिपीट ARQ में क्या होगा? सिलेक्टिव रिपीट ARQ में only the lost packet are retransmitted. So the receiver is capable of acknowledging packets individually and can buffer out all packets. Okay. So this means the sender only needs to retransmit the packet that were lost, improving efficiency compared to go back and ARQ. So why are the other options are incorrect? So यहाँ पे option A correct हो गया. In the case of go back NRP, if any segment of the sliding window is lost, all the segment of the sliding window are retransmitted. While in selective repeat ARQ, only lost packets are selectively read. मतलब only the lost packets are selectively transmitted. तो ऑप्शन ये हो गया. तो B, C, D क्यों incorrect है? B incorrect because go back NARQ retransmits all segments after the lost one, not just the lost packet. In selective repeat ARQ, only the lost packet is retransmitted. Option C Q incorrect because selective repeat ARQ does not retransmit all packets in the window, only the lost packets are retransmitted. D option Q incorrect because go back ARQ retransmit all the packets after a lost one, not just the lost packets. So selective repeat ARQ, however, retransmits only the lost packets. So you will also. So option number A is the correct right statement. Okay. In the case of go back ARQ. Question number 9. Consider a sender using the go back ARQ protocol with a window size 5. The sequence number range from 0 to 7. Modulo 8. Let's say the sender initially transmits packets with the sequence number 0, 1, 2, 3, 4. During the transmission, packet 3 is lost in the network. The sender receives a cumulative SEK for the packet 2. The sender continues sending the packet 5, 6, and 7, but the receiver denies accepting them due to the loss of packet 3. So identify the range of packets that will be retransmitted by the sender after the timeout of packet 3. Okay. So डाटा क्या दिया गया है, सिनेरियो क्या है कि in go back in ARQ, the sender can transmit several packets before receiving an acknowledgement for them. But if any packet is lost in the transmission, the receiver will expect the missing packet and will not acknowledge any subsequent packets. So consequently, the sender will retransmit all the packets from the lost packet onwards. Scenario यही है कि window size दिया गया है 5, sequence number in 0 to 7, that is modulo 8. Initially transmitted packets, that is 0, 1, 2, 3, 4. Packet is lost in the network. Sender received a cumulative SCK for packet 2. So the sender continues to send packets 5, 6, 7, but the receiver denies to accepting them because the packet 3 is lost. The receiver cannot accept any packet beyond the missing packet. So जो भी न्यूमेरिकल आप सॉल्व करोगे ना, पहले इसका सिनेरियो यहाँ पे डाटा क्या गिवन है वो पहले लिख लो, आपको इजी होगा फाइंड आउट करने के लिए, सब कुछ मतलब इवैल्यूएशन करने के लिए, जो प्रॉब्लम है ना उसको सॉल्यूशन या इवैल्यूएशन करने के लिए। ओके, तो पहले सिनेरियो क्या क्या दिया हुआ है, मतलब क्या क्या डाटा गिवन है वो आपको लिख देना है, इसे लिस्ट करके, क्योंकि आपको सॉल्व मतलब जो प्रॉब्लम को सॉल्व करने के लिए इजी हो। सो एक्शन आफ्टर टाइम आउट फॉर पैकेट 3। ओके, so after the timeout of packet 3, the sender will retransmit packet 3 and all subsequent packets, that is the packets 3, 4, 5, 6, and 7, because the receiver has not acknowledged packet 3, and therefore the sender needs to resend all packets taken from the last one. So correct answer क्या हो जाएगा, the range of packets to be retransmitted, that is 3, 4, 5, 6, and 7. So correct answer हो जाएगा 3, 4, 5, 6, and 5, 6, and 7. That is option number C. Okay. Question number 10. A client and a server establish a connection using TCP's three-way handshaking. The following details are given. Okay. So जो जो प्रॉब्लम यहाँ पे देगा ना, तो उसका डाटा पहले गिवन, क्या क्या डाटा गिवन है वो लिख लो पहले। ओके, इजी होगा सॉल्व करने के लिए क्वेश्चन को। ओके, क्या दिया गया है यहाँ पे, सारे लिस्ट को दे दी पहले से। ओके, कुछ करना जरूरत नहीं है, यहाँ पे सारे के सारे मतलब जो जो सिनेरियो है वो गिवन है एज लिस्ट वाइज, यहाँ पे कुछ करना ही नहीं है, ओनली सॉल्व करना है। तो इनिशियल सीक्वेंस नंबर ऑफ द क्लाइंट 100 and initial sequence number of the server, that is 300. Then FTT round trip time, that is 80 ms. Each TCP segment carries, that is 40 bytes of header information. The server sends a SYN SCK segment, and the acknowledgement that the SCK segment from the client is delayed due to the congestion, taking 100 ms to, okay, taking 100 ms to reach the server. So how much time does it take to establish the connection under such a scenario? यहाँ पे सिनेरियो सारे के सारे गिवन है। ओके, कुछ करना है नहीं, ओनली सॉल्यूशन फाइंड आउट करना है। So let's go through the process step by step, find the correct time it takes to establish the connection. तो स्टेप 1 में क्लाइंट क्या करेगा, सेंड से SYN to server. So the SYN segment is sent from the client to server. So it takes 40 ms to reach the server, that is half of the round trip time. Okay, half of the round trip time. So step 2 में the server sends SYN SCK back to the client. So the SYN SCK segment is sent from the server to client. So it also takes 40 ms, okay, half of the round trip time to reach the client. Then step 3 में client sends SCK to server. So the SCK segment is sent from the client back to the server. However, due to the congestion, this SCK delayed taking 100 ms instead of the usual round trip time. So total time calculation 40 ms. Okay, client to server for SON, then 40 ms server to clients for SYN SCK, then 100 ms. Okay, client to server for delayed SCK. So total time to establish the connection, that is 40 ms plus 40 ms plus 100 ms, that is 180 ms. तो करेक्ट आंसर हो जाएगा 180 ms। ऑप्शन बस। तो सारे सारे हो गया। क्या लेते हैं एक बार। क्वेश्चन नंबर 1 ए, क्वेश्चन नंबर 2 बी, क्वेश्चन नंबर 3 डी, क्वेश्चन नंबर 4 सी, क्वेश्चन नंबर 5 बी, क्वेश्चन नंबर 6 बी, क्वेश्चन नंबर 7 ए, क्वेश्चन नंबर 8 ए, क्वेश्चन नंबर 9 सी, क्वेश्चन नंबर 10 सी। सबमिट। सो अच्छे से प्रैक्टिस करना सारी चीज, तो हो जाएगा। अगर कोई किसी को कोई डाउट है तो कमेंट सेक्शन में कमेंट करना। ओके, इसका भी कोई डाउट है तो कमेंट सेक्शन में कमेंट करना। ओके, वीडियो थोड़ा लंबा हो गया। सो बहुत प्रॉब्लम था ना यहाँ पे, तो इसीलिए थोड़ा सा टाइम कंज्यूम। एनीवे, थैंक यू।